The alpha-1 adrenergic receptor is a G-protein-coupled receptor GPCR, associated with the GQ heterotrimeric G protein. It consists of three highly homologous subtypes, including alpha-1A, alpha-1B, and alpha-1D adrenergic. Catecholamines like norepinephrine noradrenaline and epinephrine adrenaline signal through the alpha-1 adrenergic receptor in the central and peripheral nervous systems. There is no alpha-1C receptor. At one time, there was a subtype known as alpha-1C, but it was found to be identical to the previously discovered alpha-1A receptor subtype. To avoid confusion, naming was continued with the letter D. Effects. The alpha-1 adrenergic receptor has several general functions in common with the alpha-2 adrenergic receptor, but also has specific effects of its own. Alpha-1 receptors primarily mediate smooth muscle contraction, but have important functions elsewhere as well. The neurotransmitter norepinephrine has higher affinity for the alpha-1 receptor than does epinephrine, which is a hormone. Smooth muscle. In smooth muscle cells of blood vessels, the principal effect of activation of these receptors is vasoconstriction. Blood vessels with alpha-1 adrenergic receptors are present in the skin, the sphincters of gastrointestinal system, kidney, renal artery, and brain. During the fight or flight response, vasoconstriction results in decreased blood flow to these organs. This accounts for the pale appearance of the skin of an individual when frightened. It also induces contraction of the urinary bladder, although this effect is minor compared to the relaxing effect of beta-2 adrenergic receptors. In other words, the overall effect of sympathetic stimuli on the bladder is relaxation, in order to inhibit micturition upon anticipation of a stressful event. Other effects on smooth muscle or contraction in ureter, uterus when pregnant, urethral sphincter, bronchioles, although minor to the relaxing effect of beta-2 receptor on bronchioles, iris dilator muscle, seminal tract, resulting in ejaculation. Neuronal. Activation of alpha-1 adrenergic receptors produces anorexia and partially mediates the efficacy of appetite suppressants like phenylpropanolamine and amphetamine in the treatment of obesity. Norepinephrine has been shown to decrease cellular excitability in all layers of the temporal cortex, including the primary auditory cortex. In particular, norepinephrine decreases glutamatergic excitatory postsynaptic potentials by the activation of alpha-1 adrenergic receptors. Alpha-1 adrenergic receptor subtypes increase inhibition in the olfactory system, suggesting a synaptic mechanism for noradrenergic modulation of olfactory-driven behaviors. Other. Both positive and negative inotropic effects on heart muscle, secretion from salivary gland, increase salivary potassium levels, glycogenolysis and gluconeogenesis in liver, secretion from sweat glands, contraction of the urinary bladder urothelium and lamina propria, Na plus reabsorption from kidney, stimulate proximal tubule NHE3, stimulate proximal tubule basolateral Na-K atpase, activate mitogenic responses and regulate growth and proliferation of many cells, involved in the detection of mechanical feedback on the hypoglossal motor neurons, which allow a long-term facilitation in respiration in response to repeated apneas. Signaling cascade. Alpha-1 adrenergic receptors are members of the G-protein-coupled receptor superfamily. Upon activation, a heterotrimeric G protein, GQ, activates phospholipase C-PLC, which causes an increase in IP3 and calcium. While DAG stays near the membrane, IP3 diffuses into the cytosol and to find the IP3 receptor on the endoplasmic reticulum, triggering calcium release from the stores. This triggers further effects, primarily through the activation of an enzyme protein kinase C. This enzyme, as a kinase, functions by phosphorylation of other enzymes causing their activation, or by phosphorylation of certain channels leading to the increase or decrease of electrolyte transfer in or out of the cell. Activity during exercise. During exercise, alpha-1 adrenergic receptors in active muscles are attenuated in an exercise intensity-dependent manner, allowing the beta-2 adrenergic receptors which mediate vasodilation to dominate. In contrast to alpha-2 adrenergic receptors, alpha-1 adrenergic receptors in the arterial vasculature of skeletal muscle are more resistant to inhibition, and attenuation of alpha-1 adrenergic receptor-mediated vasoconstriction only occurs during heavy exercise. Note that only active muscle alpha-1 adrenergic receptors will be blocked. Resting muscle will not have its alpha-1 adrenergic receptors blocked, and hence the overall effect will be alpha-1 adrenergic-mediated vasoconstriction. Ligands. Various heterocyclic antidepressants and antipsychotics are alpha-1 adrenergic receptor antagonists as well. This action is generally undesirable in such agents and mediates side effects like orthostatic hypotension, and headaches due to excessive vasodilation. See also: adrenergic receptor. References. External links. Adrenoceptors. IUPHAR database of receptors and ion channels. International Union of Basic and Clinical Pharmacology.